Hello, this is Lesson 5, Chapter 12, Lesson 5, Tobert's class. Buoyancy is a force. Buoyancy is a measure of the upward force a fluid puts or exerts on an object that's in the water. You float when you're in the pool because you're buoyant. The water is pushing you up while your weight is pulling you down. It is the equal and opposite reaction to your weight. The strength of the buoyant force on an object depends on the volume that the object is under the water, because when you're in the water you displace that same amount of water. And as you already know, we've talked about weight before. Weight is a force like any other pushing or pulling force. It's caused by gravity that's pulling down. And as we know in the past, it's easy to confuse mass and weight, but we know it's not the same. When you're talking about weight, weight is the downward force of gravity acting on the mass that makes you up. In 3rd century BC, a Greek mathematician named Archimedes realized that the buoyant force was equal to the weight of the fluid displaced by an object. He did this experiment when he put the king's crown in water and it displaced some water. The king asked him to figure out if it was made of gold or not. And supposedly Archimedes came up with this when he was in the bathtub. He was in the bathtub, he filled the bathtub to the top, he got in and overflowed, and he said, "Eureka! I displaced the same amount of water equal to my mass." So, buoyancy is a force with which a more distant fluid pushes up less distant substance upward. In short, it's the ability to float. So here we've got the rock out of the water, and then the rock submerged in the water. The difference between its newtons of force out of the water and in the water happens to be 9.8 newtons, which is exactly the same amount that it exerts when it's in the water. And you might remember 9.8 because that is also the acceleration due to gravity. Notice these two blocks. These two blocks have exactly the same amount of volume, but they're going to displace a different amount of water because one is a little more dense. You've got a foam block and a wood block. Wood is more dense than foam. And you might also notice that the distance at which the wood block is in the water. Look, it's deeper in the water, so it's going to be pushing more of the water aside. Buoyancy depends on some objects, as why some objects sink and others float. A couple things. You've got a 5 centimeter steel ball and a 5 centimeter wood ball. It's all about their density and their density compared to water. You should have in your notes, water's density is equal to 1 gram per milliliter. If it is greater than 1 gram per milliliter, it's going to sink. The steel ball is greater than 1 gram per milliliter. It happens to be 7.8, whereas the wood ball is 0.75. So the wood ball is going to float. All about the average density. Average density helps you determine which objects are going to sink and float. Remember, this is a comparison to water, or 1 gram per cubic centimeter. An object with the average density greater than the density of water will sink, and an object with an average density less than the density of water will float. So if you have these same two balls and they're exactly the same amount of volume, and you push the wood one underwater, then at that point, if it's all the way submerged, both balls, they will displace the same amount of water. Displaying the same or equal buoyant force. And this is a great explanation about how average density can be changed if you have something that is solid steel versus something that is hollow. Notice on the left, the average density of the solid steel ball happens to be 7.8 grams per milliliter, while on the right, the average of a hollow steel ball happens to be 0.8. Because it is less than 1, the hollow steel ball is going to float. We can use our understanding of average density to explain how steel boats can be made to float. It's all about how many open spaces that they have. If the overall average density is less than 1, it will still float. So this is the end of Lesson 5. If you've seen an unloaded cargo ship in the bay, you might notice the red on the ships underneath. Notice the ship on the right has more red showing above the water. That means it's totally unloaded. There's more of the boat above the water than below the water, or submerged. As you load it heavy, more of the boat goes down deep in the water, and it will displace, it will sink deeper in the water.